The design of audio is half the story when creators make video content. In particular, spatial audio, a type of audio effect that allows listeners to perceive the position of sound sources in a three-dimensional space through surround sound, can significantly contribute to improving the immersion of video content for viewers. However, the adoption of spatial audio among video creators remains limited for video content creators due to the relatively high cost of the recording devices, lack of spatial audio source files for previously recorded videos, and hard to post-edit the spatial effect when the audio track is remixed. To address these problems, we proposed Mimosa, a human-eye collaborative tool for computationally generating and interactively editing spatial audio effects on videos with only binaural or stereo audio. Specifically, on the AI side, the machine learning pipeline separates the video into visual frames and independent audio tracks, identifies the potential sounding objects in each frame, predicts the 3D positions and uses the coordinates to spatialize the corresponding sounding object. Meanwhile, it provides intermediate results for users to understand, validate, and adjust. After that, users can edit those intermediate results through Mimosa's user interface, which consists of several interactive panels. To illustrate the usage of Mimosa, we demonstrate an example use case where the user already has a video with the binaural audio of a duet band playing in a room. The user wishes to augment the video with immersive spatial audio effects. The user first starts Adobe Premiere Pro and loads the target video clip. From the Extension menu, he launches Mimosa. The audio spatialization pipeline will run in the back end. The results of the pipeline will be visualized in the video preview panel in the 3D direct manipulation interface. Using these features, the user can view the predicted sounding objects and make edits if needed. In the video preview panel, several dots of different colors are shown in a 2D overlay on top of the video playback to indicate the inferred positions of the sounding objects. Inferences are inaccurate, the user may directly drag these dots to align them with the actual sounding objects in the video. At the same time, a 3D direct manipulation interface visualizes their positions in a simulated 3D space, allowing users to adjust the positions in a 3D space at a finer granularity. The user can select an output format, and the surround sound with spatial effect will be rendered in real time for preview based on the 3D positions of each sounding object. The sound intensity of each channel will also be visualized to indicate the output of each channel. In addition to predicting the positions of sounding objects for generating realistic spatial audio effects that resemble the ground truth, content creators can also create customized spatial audio effects with Mimosa. For example, the user can adjust the location and orientation of the reference point by directly manipulating the camera icon in the 3D interface. Instead of having the band play in front of the viewer, the content creator may move the viewing point to the back of the band, near the saxophone player, or between the two players. They may also manipulate the positions of sounding objects so that the sound sources can, for example, move around the viewer or out of sight towards the back of the viewer. We present the following three main contributions. A new human-AI collaborative pipeline that allows content creators with no specialized expertise in spatial audio to generate computational spatial audio effects for existing videos and to manipulate the spatial effects of generated audio in a flexible way. Mimosa, a practical system that implements the aforementioned pipeline with an easy-to-use direct manipulation interface that lowers the barrier and increases the expressiveness of computationally generating spatial audio effects in existing videos for amateur content creators. A user study with 15 participants demonstrated the effectiveness of our approach and the usability of the Mimosa system.